Pythagoras theorem. Pythagoras theorem holds for right-angled triangles. So let us now try to find out what is a right-angled triangle. Here I am showing you a right-angled triangle in the figure. It has three sides. AB and AC are the sides which form the right angle. The right angle is formed at A. The side which is opposite to the right angle is BC and it is called the hypotenuse. The hypotenuse is the longest side of the right-angled triangle. Here, the three sides of the right-angled triangle are AB is 3 centimeters, AC is 4 centimeters, and BC, the hypotenuse, is 5 centimeters. AB and AC are called the legs of the right-angled triangle, and they are always shorter in length than the hypotenuse. So now let us see another figure in which I have drawn squares on the sides of the right angle triangle which I showed to you. The side which is 3 centimeters long, I have drawn a square 3 centimeter by 3 centimeter. On the side which is 4 centimeters long, I have drawn a square 4 centimeter by 4 centimeter. And the side which is 5 centimeter long, I have drawn a square 5 centimeter by 5 centimeter. Also, I have divided the lines. Can you see the dots on the lines? The 3 centimeter side, I have divided it into 3 parts. Each part is 1 centimeter. Similarly, the 4 centimeter side also I have divided into 4 parts, each part being 1 centimeter. Same way, the 5 centimeter side has been divided into 5 parts and each part is 1 centimeter. The lines which form the square also, I have drawn dots on those also, and all the sides have been divided into parts and each part being 1 centimeter. Now we join the dots. If I join the dots, what I am getting is a figure or a diagram something like this. There are 3 squares on the side of the right triangle, and this square forms a large number of small squares. This square also forms a large number of small squares. This square also forms a large number of small squares. Now each small square is 1 by 1. That is, each small square is 1 centimeter square. 1 centimeter by 1 centimeter. So now let us count the number of squares in each of these squares that are formed. For this, we can use this figure. Now if you see this figure, can you see how many small squares are there in this side square? 9. How many small squares are this here in the 4 centimeter by 4 centimeter square? 16. And how many small squares are there in this 5 centimeter by 5 centimeter square? 25. So now I have 3 numbers. The 3 numbers are 9, 16 and 25. Let's see, is there any relation between these 3? Oh yes, 9 plus 16 is equal to 25. I can write 9 as 3 multiplied by 3. I can write 16 as 4 multiplied by 4. And I can write 25 as 5 multiplied by 5. Now 3 multiplied by 3 is equal to 3 square. 4 multiplied by 4 is equal to 4 square. And 5 multiplied by 5 is equal to 5 square. So I have written the next line. 3 square plus 4 square is equal to 5 square. Oh, but 3, 4 and 5 are the sides of the right angle triangle. 3 centimeters is AB, so AB square plus AC square is equal to BC square. And AC is equal to 4 centimeters and BC is equal to 5 centimeters. So from this, I've got the Pythagoras theorem, which states that the sum of the squares on the legs is equal to the square on the hypotenuse of a right-angled triangle. Now, the Pythagoras theorem holds true only for right-angled triangles. Now let us see what we've studied today. We have studied that in a right-angled triangle, the sides which form the right angle are shorter than the side which is opposite to the right angle. The side opposite to the right angle is called the hypotenuse, and the shorter sides of the right triangle are called the legs of the right triangle. And Pythagoras theorem states that the sum of the squares on the legs of a right angle triangle is equal to the square on the hypotenuse. Hypotenuse is the longest side.